but go ahead and take it away, Kevin.
All right. Well, thanks everybody for joining me today. My name is Kevin Dilley. I'm from Explorer Science Museum. Today, we're going to go over Arduinos, and this is part 2. So in the first one, we had an introduction to Arduinos. This one, we'll go over a few more kind of sensors, things like that, that we can connect to the Arduino and how to control them. We're going to be going through some different activities that are from the SparkFun Inventors Kit. So I believe that the kits that you guys were provided from New Mexico Mesa are the SparkFun Inventors Kit. It comes with a little guide. There's a virtual guide as well. Just to save a little bit of time and typos, there you can download the code for the different activities that are in the SparkFun Inventors Kit guidebook. And the way to do that is to go to, let me put this in the chat. Give me just a sec. There we go. So it's sparkfun.com/SIK code. And I put in the chat. I'll also share my screen as well. There we go. On the web page, it'll look something like this. So we can go here to download the code. It'll download a zip file. You can open it up, and then we will be able to upload it to our to the Arduino example library. That way it'll be easy to get to the code instead of having to type it out. That can just take a while, and there's always typos and things like that when we're typing out code. I'm sure you guys all know that. So go ahead and do that. You can download the latest one, the 4.1 code, and then I'll show you how you can upload it to your Arduino library. So for that, let me just share my whole screen, actually. Share my desktop. So hopefully you have your Arduino downloaded to your computer, the Arduino app. If you are on a Mac, the way to send that code to your library, that way you have it in your library. So for example, if you're in your Arduino, the Arduino app, and you go up to File, you can open up examples, and there are some built-in examples that come with Arduino. And what we want to do is download these ones that are the SparkFun Inventor Kit, the guide. They're examples. Those are the ones that we'll be using today. And this is something that might just be really helpful for you as well, having that kit and the directions for that guide. These ones are there. And the way we can get these into our library is if you are on a Mac, what you're going to do is you're going to open up a Finder window, and you're going to find your Arduino application. So you can go to Applications, and here's my Arduino one. If I right-click on it, it'll ask me to show package contents, and we'll go into the contents and drill down into Java and into examples right here. And this is where we would copy that file. So right here, I've already copied mine in there. The directions for this are also in the SparkFun Inventors Kit guide. So if you have the SparkFun Inventors Kit guide, if you go to page, I think it's page 7, go up to page 7, it'll have the directions for how to, maybe it's 7, no, not there, a little bit further up. There we go. So right here, it'll show the directions on how to download that file, where to copy that file. So on a PC, you're going to go to your local disk, go to Program Files, Arduino, and Examples, and just copy that file into there. Like I said, for Mac OS, you're going to right-click on the Arduino app itself and do show show package contents and then drill down to contents, Java examples, and copy it on there. So that is what we are hoping to have available to us. One of the first activities I was hoping to go over today was to look at how we can use some different sensors. So one of the sensors that I was wanting to go over today was the ultrasonic sensor. So it is one that uses sound to be able to detect things. So it will look something like, stop sharing my screen. It looks something like this. It kind of looks like eyes, actually. So the ultrasonic sensor, it has these two different parts to it, or two different kind of cylinders on it. One is the emitter and one is the receiver. So the way that this one can detect, can sense things is that it sends out an ultrasonic pulse. So it's a sound that's ultrasonic, something that's too high for us to be able to hear. It sends it out of one, reflects off of something, and then comes back and is sensed, is received in the other one. And so with this, we're able to determine distance to objects. And so it does it by the amount of time it takes for this, whenever it's emitted and when it's received. So the distance is going to be that time. There's an equation to be able to figure out what it is. So in the software for this, in the code for this, it'll help to determine, measure what the distance is by the time it takes for it to receive that sound back from some object that it's bounced off of. And so what we're going to do is we're going to create a little, do a little project that uses this. And so we'll do it from the SparkFun Inventors Kit guide. It is circuit 3B. And so what we're going to do is, let me pull it up. Let's pull up the circuit diagram. So we'll look at how we can connect the circuit together, and then we'll go over the code. So let me share my screen here. All right. So right here, here's our hookup guide. So when we're looking at our Arduino, we have, so hopefully you all have your Arduino kit with you, right? So we're going to be looking using our Arduino, so connect up things to the Arduinos using our breadboards to be able to connect the different devices or objects to be able to use in our project. And so you'll notice here in our hookup guide here, our circuit diagram, that we have, we're going to put our ultrasonic sensor here on the breadboard, and we're going to hook up the different pins to it. You'll notice it kind of does a little blowout of what the pins are. So we've got the power one, it's labeled VCC. The pulse, the trigger pulse, that's the input, is the one that's labeled TRIG, trig. The output is labeled echo, and then ground is labeled GND. And so those are how we're going to hook up those things. And we're going to hook those up so that the input, so the trigger pulse one, is we're going to go to pin 11. For the echo, we're going to go to pin 12. And then, of course, for VCC, we're going to go to 5 volts. And for ground, we're going to go to ground. So I'll leave this up on the screen for you to be able to use this as your for pinning your project. But also, if you download that guide, and to download that guide, let me put that in the chat really quick as well. So to download that guide, you would go to this link. Okay, so you go to this link and click on documents, and then you can download the printed guidebook. Okay, let me go back to my pinout here. And so we're going to hook up our, let's go ahead and just hook up our sensor first. So to do that, we're going to be clipping in using the pins. If you haven't used breadboards before, on the breadboard itself, there are different rows and different columns that are connected underneath. And so on the breadboard that comes with this, the two columns on the left and the two columns on the right, they are connected vertically, so up and down along the columns. Those are each connected in each of those columns. In the center, they're connected horizontally. So you'll notice that there are how many? There are 5 of them. And then there's a divider in the middle and then 5 more. And so each of those 5 are connected horizontally along each row, but they're not connected between the different rows with the center thing. Okay, so let's go and hook up our boards, and I'll do mine on screen here that I'm hooking up. I'll leave the pinning diagram there up just so folks can see it. But if you need to be able to see my board a little bit more, just let me know and I'll stop sharing screen so that my image will be bigger. But to do this, we're going to be using our jumper cables. So those are the wires that are in your kit. There are lots of different colored wires. The colors aren't important in that all the wires are the same. The colors are just there to help you keep track of one wire from another. So I tend to try and get them so they correspond to the colors in the diagram, just to help keep my mind straight. It makes it a little bit easier. But if it doesn't correspond exactly color-wise, that doesn't matter as long as the wires are going to the right places. So I'm going to take my red wire first, and I'm going to go from, and actually one thing I should mention here is when we're creating our circuits, the best way to do it is to do it without your Arduino plugged in. So without power is the best way to do your wiring. That way, in case you put wires in the wrong places by accident, you're not frying anything, okay? It's better to hook it all up first, double check it, make sure that the things are connected in the right way, and then plug it in, okay? So I'm going to take something from my 5 volts on my board. So on my board, there's a 5-volt pin here that I'm going to do, and I'm going to put it to the bottom of this positive column here on this. So now this whole row or this whole column is energized, will be energized with 5 volts. I'll do the same thing with a black wire going from ground to the black to the next column there. That way I have that whole column will be ground. So now in my circuit, anytime I want to go to ground or to 5 volts, I can just go to these columns instead of having to go to a pin on the board itself. Okay. So I'm going to start with my ground from my sensor. And I'm just double checking to make sure I'm going to the correct row and going to ground. The next one, I'm going to do my, let's see, do I have a purple? I don't have a purple, but I have a blue. I'll use a blue one instead of purple. And so that's going to go to my echo. So that's the output one of my sensor. And I'm going to have that one go to pin 12 on my Arduino board. And it's important we go to pin 12 on this because the code that we're going to be using refers to pin 12 for the output. If in our code we change it to a different output pin, then we'll have to change our wires within our circuit. I'm going to get a yellow one and go from the trigger. So that's the input on my sensor, and take that to pin 11. There we go. And let me do a 5 volts from the VCC pin. So that's the power pin, and go to that. And so there I've got mine hooked up in there. And the next thing we're going to do is we're going to hook up an LED, so a light emitting diode, and you should have in your kit kind of a special, an RGB LED, red, green, blue light emitting diode. So it's one that has 4 wires coming out of it. So this is one that you can, depending on which of the wires you have electricity going through, you can turn on a red, a green, or a blue LED. And so I'm going to put this, and you'll notice on the LED itself, and it shows on the diagram there as well, that there is one side of it is flat, actually. So we have kind of like a cylinder that is encasing the LED, that plastic cylinder. And one side of it is flat compared to the other. If you feel it, it's not rounded, it's got a flat edge to it. And that is the one that we want to put oriented in a specific way. I'm going to orient it so it's facing kind of towards me. And I'm putting each of these wires from the LED into a different row of the breadboard. Okay, that way we can use those different rows to get to those different wires on the breadboard. We're also going to need some resistors. So with any resistor, or sorry, with any LED, we want to make sure we're not going to blow the LED. And so we're going to use some resistors to limit the amount of the current that's coming into it. And so when you get your resistors, look very carefully on your resistors. We want to get ones that have the right color bands on them. So the color bands on resistors help to tell us what the resistance is on it. So these resistors that we're going to get are going to be, I think, what are they? 330 ohms, I think is what they are. And so you're going to look for ones that have a, it's like a silver, brown, orange on them. So it's going to look like this. It's kind of hard to see the resistor itself on the screen, but you'll probably have a couple different resistors in your kit. We're going to look for the one that has the brown, or sorry, I guess that's still gold, brown, orange that we want to do. So we're going to get 3 of those. Let's see, I've got one here, there's 2, and one more. Mine out. Okay, there we go. So I've got my 3 here. And when we're putting these on, you'll notice that there is, and one other thing you'll notice with the LED light is that on the wires themselves, get a good background here for it to show on screen. Put a white sheet of paper here, see if that works. On the wires themselves, actually the white's not working. Let's get a darker thing, blue.
Evan, there's a question in the chat while you're doing that. What's the resistance of these resistors? I know the colors signify the voltage, but I don't know what the one you're using.
Yeah, so the one we're going to use are the 330 ohms ones. So that's the I think it's silver, brown, orange, or is it gold? Gold, brown, orange. Yeah, so it's 330 ohms. But you also notice on the LED, the different wires, one of them is a different length. Okay, the one that's longer there, that one, just kind of pay attention to which one that is that has the longer wire on it. That's the one that's going to be going to ground. Okay, so the other ones we're going to hook up to different pins. That one with the longer wire, that's the one that's going to be going to ground. So I'm going to put mine into my breadboard here. And I'm going to connect a resistor. And when I do my resistors in our circuits, if we just put the resistors in the same column, or sorry, in the same row as those, the wires on the LEDs, and then just go to the same one. We're not going to be going through the resistor. So here, let's see, can you see that there? I have this one right here. Notice how it's still in the same column, the one part of it and the other. Let me stop sharing screen. Maybe that'll help a little bit to see this. So on here, I have my resistor still in the same column, row here. And so for a circuit, this would not work because the electricity would just go along the row and kind of bypass this resistor. Electricity will just bypass it if there is. So it's going to short circuit this resistor. So I want to make sure that I want to make it follow. So I'm going to have one leg go in this row on this side of the center line and have the other leg go onto the other side of this center line. Okay. So now each of these legs are going to be in a different row, so that electricity will have to go, the current will have to go through the resistor if I put a wire over here. Okay. So we want to make sure that we do that for all three of the short wires that were on my LED. And for the longer one, the longer wire, we're going to put that one to ground. So let's put 3 resistors here. Each of these things. And when you're putting your resistors in, one thing to just kind of be careful of is make sure that the resistor wires aren't touching the other naked resistor wires. We don't want to have things going into other rows. Okay. So now I've got my 3 resistors, one for each of the different ones. I'm going to start sharing my screen again so that we can see the wiring diagram. Okay. And now I'm going to pin, or I'm going to use the jumper cables to take each of these to a different one. So the bottom one, the one that has the flat edge, that one is going to be our blue LED. So I'm going to take a blue wire for that one, and I'm going to put it to pin, I think 6 is what we have. Yep, pin 6. I'm going to get a green wire, and so that'll be, well, actually, I'll take a black wire next. And so the next part of the LED is going to go to ground. So from that row, I'm going to put it to ground. And you'll notice that as we're creating these different circuits, we're going to get a bunch of different wires, kind of loops coming up and over. And, you know, it seems a little bit chaotic, but this breadboard actually makes it so much easier to keep track of things. Just imagine if we didn't have the breadboard, right? It could be quite the warren of wires there. The next one is going to be my green LED. And so I'm going to take it from that next wire and put it into pin, I think we have it in pin 5. Yep. And the last one is my red LED. So I'm going to get a red wire. Put that one to pin, I think we have it at pin 3. There we go. So there is my wired circuit, just like we have in the hookup guide there in our wiring diagram. And oh, I see somebody didn't have an ultrasonic sensor in their kit. Do others have ultrasonic sensors in their kits?
So I only got, I have what was sent to me was the, this is Manny, was the Tinker kit. I
Okay.
don't know where my camera's, maybe, let me see, I might be in the wrong. Yeah. It was the Tinker Kit. So the Tinker Kit does not come with the sensor. That's what I received from Mesa. It's only like $4, but I mean, it's a little bit too late for me to buy it, right, to do this, but
Sure.
I'm following what you're doing, and I have the guide as well. It's just that, yeah, I don't know if everybody got the same type of kit or not. But that's why I put the comment there.
Yeah,
Um,
no,
Anita-
everyone did get mailed that kit, Manny, so I
The same
apologize
one?
for that confusion. Yeah, no, it was the Tinker Kit, and I guess I just
okay.
confused the two. But it was, yeah, we've used the Tinker Kit and it's to past distribution. So I had thought it had the ultrasonic sensor in there, but I guess it did not.
Okay. Well, that's fine. Well, in that case, let me just demonstrate this then. But go ahead, it's good practice to hook up the other things that you have, right? The LEDs and such. We can, let's see, we can modify the code for you guys so that hopefully we can do something with your LEDs, even though we don't have the ultrasonic sensor. Let me just think, what other thing might we have in your kit that you could use? Put a button in there as well, so we could, well, anyways. So let me just go over this with the ultrasonic sensor first just to demonstrate it. So this is our wiring diagram for it. So hopefully, if you have the ultrasonic sensor, you've hooked it up. I've got mine hooked up like this. And again, one of the things to really be careful of, especially with the LED, is noticing which are the different wires that you're hooking up where. Make sure everything's in line, and that you have the correct side, the one that has the flat side, facing to one side, and that way you can know which one. So the red one is the one that's the short wire, it'll be short wire red, long wire ground, short wire brown, or short wire green, and then short wire blue. That's kind of the orientation of those ones for that RGB LED. And so now let's look at the code for this. So that's the wiring diagram for it. Let's look at the code now, and let's let me move to a different screen here.
Can you put it back for a second? I will just take a picture of it. So
Sure.
thank you.
You can also get this this whole document that has this wiring diagram. I think I put it in the chat. Let me do it again. It's yeah. So in the chat, I just put the link to the Inventor's Kit guide, and if you go to that page and click on Documents, it'll allow you to download this guide that has this wiring diagram in it.
Yeah, thank you.
You're welcome. So let's go to our Arduino app. And so here is our Arduino app. And actually, so to get to the file here, you would go up to File. Actually, let me stop sharing this. Let me share my whole screen so you can see the file menus. All right. So if we go to Arduino, the Arduino app, I have it open right now, but to get to it, if we go up to File, go to Examples, and if you've downloaded the Inventor's Kit Guide Code Master, it'll bring it here. And this is the 3B project. And examples, Inventor's Kit Guide 3B, the distance sensor. And this will bring up the code here. Now, if you've ever used Arduinos before, this will look somewhat familiar. If you haven't really, this might be a little overwhelming, but it's not that bad. So when we're looking at code, and this is always something to do with students as well, Sometimes it's nice to have them type in the code themselves, but sometimes it's good to just show them some code and have them try and read it, right? To become familiar with what this code is telling us. So a couple things to note with code here in Arduinos is when things are just notes, okay? For Arduinos, we can have things as just comments if we use this slash and then asterisk. That and then anything between that and then the asterisk slash is just a comment. So that's not part of the code. That's just that allows you to type in some things, to just some text to help people get some context, or to explain something in the code. We can do that. And the slash asterisk one allows you to do multiple lines as a comment. If you wanted to do comment just within a single line, you can use a double slash here. So right here, this right here is another comment. And this one's just a comment. Anything following the double slash is a comment until it gets to the next line, and then it's no longer a comment. Okay, so this is to make a comment just for a single line is the double slash. A comment with multiple lines is the slash asterisk. And so this code is nice because it has some comments in here to help us explain what's going on with the code here. So the code here, we have this construct integer line, this line of code here. So construct integer, C-O-N-S-T space I-N-T. What this one does is it creates an integer. An integer is just like a number, something that's gonna be a number that's like a whole number, okay? Now, in this case, we're creating one that we're creating an integer for the trigger pin, and we're telling it to use pin 11. And that's what we had plugged in our circuit to make, right? So that the trigger pin goes to pin 11. We did another one, constructing an integer for the echo pin, telling it that it will get the input or the output from that through pin 12, okay? We're gonna do similar things for the red pin, green pin, and blue pin. And so we're putting those in 3, 5, and 6. And so looking at the code, we can just double check also. We can look at our circuit and just make sure that it's corresponding to what we have in our circuit, right? You can look and make sure that your echo one is going to pin 12, the trigger is going to pin 11, and so on. And these integers that we're creating, we're giving them a name as well, right? So we're creating this one that's called trig pin, echo pin, red pin, green pin, blue pin. And so we're giving them their names. And then this last one here, this one that says float. So this one, we're creating a floating, so it's not an integer like the other ones where it's a whole number. So the float is something that allows us to be able to use a number with decimals, okay? And so that's important in some instances. Like for this one with the distance, if we want to measure distance between, from the sensor to something else, we don't want it to be, whole numbers of, maybe like, 2 feet. Maybe we want it to be, 2.5 feet or something like that. So we need to have an integer for that instead of a whole number, or something with a floating decimal point instead of just an integer as a whole number. Okay. And then the next part that we have here, this one that has the void setup, this is going to be telling us kind of this is the stuff that is the kind of setup stuff for our program. So you'll see that this at the beginning of kind of all of your programs. These are the kind of setting the different parameters to it, okay? First thing we have here is serial begin, 9600. This is going to be connecting the serial connection to the computer. So this is telling the program that this thing that we're connecting to the computer, our Arduino that we're connecting to the computer, we want to be able to read the number that's coming out of it. We want to be able to read the distance here. And so this is setting up that serial connection, and it's saying it's at 9600 baud. So that's the rate that it's sending information back and forth to the computer at. And that's nice, because then we can look in our on the computer to get a readout of that distance over time. We can see what that distance is at any moment. The next things that we have are telling what mode we want the pins to be in. So these different pins that we have on our Arduino, they can be inputs or they can be outputs, right? They can send a signal out or they can receive, but the code, the program needs to know which one that we're expecting it to do, that we want it to do. And so here we're telling that we want the trigger pin to be the output, we want an echo pin to be an input. So this is telling the program that we're going to send stuff out in the trigger pin, we're going to be receiving information from the input, from the echo pin. And then likewise for the RGB LEDs, we want to put those as outputs. We're going to send a signal out to be able to turn it on or off. Okay. Now then the next part of the code is we're going to look at these are the things that are going to be happening during the program. Okay, so we're going to create a variable here, which is going to store the distance measured by the sensor. And we're going to print in that serial connection to the computer what that distance is. And we're going to print it in what units to use, so in inches. Okay. And the next thing we're going to do is we're going to create an if statement, an if else statement. And we're going to say that if the distance is less than or equal to 10 inches, if the distance is less than or equal to 10 inches, we want to turn on the red LED. Okay, so if the object is really close, we're going to turn on the red LED. If the distance is greater than 10 but less than 20 inches, then we're going to turn on the yellow LED. And if neither of those things are true, meaning that if it's greater than 20 inches away, then we're going to turn on the green LED. Okay, so there's kind of three different states that we could have. If something's closer than 10 inches, if something's between 10 and 20 inches, and then anything else, which would cover anything over 20 inches. And so it will do that. And so it's going to do this as a loop, right? We have it as a loop. And so it's going to go through this if statement, and then it's going to delay 50 milliseconds between each reading. So this delay is measured in milliseconds. So 50 is there. So 50 milliseconds would be a fifth of a second. So it's, it's pretty quick that it checks this over and over again. All right, so 1,000 milliseconds is a second. So 50 milliseconds is a fifth of a second. Let's see. And so then the next thing here is this is looking at the distance. Okay, so this is how to measure, and this is something that's coming from the sensor itself. These are that the sensor sends out something it sends out a signal, and so it's going to take that time. It measures the time that it takes for it to send out signal and to get it back, and then it's gonna we're going to use that as the time. And then it's going to calculate the distance from that time. And we want to send out pulses that are 10 milliseconds long. And so here's the code to do that. So we're going to write to the trigger pin. So this is the output one. Turn it to high. So that turns it on. Then wait 10 microseconds. And then turn it off. And so that's going to send out that pulse and send it out for 10 milliseconds. And then we're going to see what time the pulse comes in from the echo pin. And then we'll see what that time is that's measured between when it's sent out and when we receive it, and then divide it by 148. And so that's half the bounce time multiplied by the speed of sound. Okay, so and that'll give us our distance. So that's the code for this distance sensor. So if I hook mine up, fingers crossed, let's hope this works. Check the chat real quick, make sure any questions. Okay. All right, let me stop sharing the screen here. Let me plug in my Arduino. When you plug your Arduino in, oops, come on. You'll notice that you should get some power to it. So once it's plugged in, you should be getting power. You should see the green light is on there. Okay. And to be able to send this code to our Arduino, I'm going to go back to sharing my screen. All right. We're gonna, well, actually, the first thing we should do is verify it. So there's the check mark here. You can click on that. It'll verify your code. So it's compiling the sketch here. You can see at the bottom, it's kind of compiling the sketch. So what this does is it just kind of checks your code to make sure that everything is good. If there are any syntax errors or anything like that, we'll see a notice down here about which line it's on. And I'll usually highlight where it is. So that helps with any debugging that we have. So we can see it's been done and there's no problems with the code itself. And so now I'm gonna upload the code to my Arduino. And so we click on the upload button and get it. And as it's uploading, you'll notice that on your Arduino board, there's some lights that are that would be flashing when it's sending the code over. So right now, here is, stop sharing the screen here. Okay. And it's got my green going. So let's see. So if I put something close to it, let me put the sheet of paper here. So far away, it's still green. As I bring this piece of paper closer, now it's blue. So you can see that on screen. And as I bring this even closer, it should turn red once it gets close enough. Oh, I'm not getting anything there. And I got my green working, my blue is working, my red. Let me check my wires here. Just make sure those are all in the right way. They're not touching anything. Yeah. Oh, I'm getting my red. What's going on with that? I wonder. Let's just do a little quick troubleshooting here. I'm wondering if my LED red might be burned out. In which case, I am going to grab another one. I think I have another one here. Plug this one instead in and just check to see if this one works with it. So this, I'll have to say, is the biggest part that I find with Arduinos is troubleshooting, which is not a bad thing. It's a great skill to teach students to be able to try and isolate what things are wrong with it. So actually one thing I'm going to check is I'm going to check my connection, make sure I'm plugged into the right places right now. So my red one is plugged into 3 and it's in the right one. I've got my, yeah, so those wires look to be fine for that. So I'm gonna unplug while I'm doing my changes. Take out that LED, let me replace with another one. And let's see. Should I get the pins here on the breadboard?
Kevin, where can we copy the codes for it?
So to copy the codes, there is, if you go to, let me put in the chat here, sparkfun.com/SIK code. There we go. And so that'll let you be able to download the code and you'll want to upload it into the Arduino examples library.
So which one here?
So,
Like
yeah, you could do the most recent one, the 4.1.
4.1.
Yeah, go ahead and use that one. All right, so I've got my new LED in there. Let's test this out. So it should still have my code in it. And oh, I'm still not getting the red to go. I'm wondering if, so I'm guessing it's not the LED. The wires seem to be in the right places, but we could always have a bad wire too. So sometimes these jumper cables, just from use or bending, they disconnect, and so it doesn't. Sometimes they're just bad. So I'm going to replace this wire, this red one here. Let's see if that changes. Still nothing. I'm wondering if it's my sensor, then I might have to, the next thing I would do, I don't have to have another sensor here, but I would do another sensor to test it out to see if that is what the problem is. So, it's just kind of isolating, just trying. This is a great example of like the scientific process, right? Just kind of looking at what are the different variables that could contribute to this not working, and then check one of those variables at a time, right? So I guess maybe the next thing I would do is check my resistor. So I might just replace the resistor there. If that doesn't do it, then I would check the sensor, try out a different sensor in there. So so that would be kind of what I would do as an example of how to use this type of sensor with students, is to do this. And then the next part that I would have them do is to test it out in a couple different ways. So with this, we say that it's measuring 10 inches and 20 inches to see when it changes the distance, it changes the color, right? And so what I would challenge them to do is to verify that. That's what the code is saying, but is that what's actually happening in real life? So I might have them get rulers and try and measure out those distances and see if there actually is that transition whenever we put an object 20 inches away, or 21 inches and then 19, does it change? If I do it 11 and 8 inches, is it different? So that would be something that you could have them do. Then in the code also challenge them to try and see how they could change the code to modify it for other distances. So if we're looking at the code just as a group here, what would I change here to be able to make it so that it would change the colors at different distances? What do you guys say?
You just change the values in your if statements.
Okay, so change the values in the if statement. So these values here, right? So this distance, if the distance is less than or equal to 10, right? I could change this to 15 or 20 or something like that. Or I could change, and I can change this one. And always be aware that for these if statements, right? This is giving you if it's this in this region, otherwise, if it's in this region, and then this is for any other thing. So you want to make sure that kind of these two regions make sense to you in lining up. So if this says, if the distance is less than 15, let's say, and then this one is still at, if it's between 10 and 20,
Could you
then
share your screen
what would
again,
happen?
Kevin, please?
Oh, I'm sorry. I forgot to share that. Yep. So in here, right? So this distance here, so in the if statement, if it's less than or equal to 10, do one thing, turn on the red LED. If it's less than or equal, greater than 10, but less than 20, turn on the yellow. And the green one would be any other thing. So this would be how we would have to, these were the things that we'd have to change, the 10s and the 20s to be able to change that. Okay. All right. Any questions or comments about this activity?
And I did want to apologize. I think when you said Inventor Kit, I just agreed because I thought that was the name of the kit, but it is the Tinker. And I think the only one that we didn't have was the closeness, whatever it's called, the
ultrasonic sensor. That's all right.
Ultrasonic sensor. But I did put a list in the chat of all the sensors that are in the kit that we had, just so that you're aware of
okay.
the kit that they do.
All right, let me see. All right. Well, let's change up what we're doing today then. I was thinking we'd do some more stuff with this sensor, but let's do some stuff with the servos then and see how we can control motors using Arduinos. And this is something that's probably one that could be really interesting to folks, because to students as well, because of robotics, right? So for robotics, they're often, you have to control a wheel to be able to move your robot somewhere. So let's look
garbage disposers.
Next hour.
Okay, I was close.
And so let's
Oh,
What are you looking for?
make sure I'm. Oh, I
somebody's not
apologize.
muted there. And so let's look at one of the other projects here. Let me find it in my sheet here. Let's look at how to create or to control a servo. And so let's do this one. Let me share my screen. All right. All right. So we're going to just start with this simple one for controlling a servo. So a servo is kind of a fancy name for a motor when you're a specific type of motor. So you should have a servo in your kit. And actually, let me stop sharing real quick just to show you this. So there are two different types of servos. There are ones that are called positional servos. So those are ones that you can control the motor and it goes between 0 and 180 degrees. Okay, and you can tell it a specific degree to go to, and that's what you're controlling, the position of the motor itself, the servo. The other type of servo that they have is one that's called a rotational servo. And so that's one that spins around all the way around. And for that, when you're controlling it, you can control how sometimes the speed of how fast it's spinning and the time that it spins for. And so with that one, that's the type that you usually use for wheels on a robot. So for arms, you would probably use something like a positional one that you can move to a specific angle to do something. For the wheels on it to make it move, you would use a continual rotation, a rotational servo in which it would spin, and you can control how long it spins, which would mean that it would move a certain distance in that time. And so we're going to look at how to control the servo with our Arduino. And so to do that, let's go to our wiring diagram, and we're going to use a potentiometer, so like a dimmer switch. So you should have a dimmer switch. I think it's probably blue. It'll have a little dial on the top, and it'll have 3 pins on it. I'm going to unplug my Arduino here so that so this is good practice. Anytime that you're doing some wiring, unplug your Arduino so that you're not going to accidentally fry anything, because it does, some of the wires do send out 5 volts, and if we put things in the wrong places, we could fry some different components or even the board itself if we send it into the wrong place or stuff like that. So it's just always good to unplug it when you're doing your wiring, then check your wiring to make sure accidents sometimes happen, but check your wires, make sure in the right places before you plug in the power source. Okay. So what we're going to do is let's go ahead and use our the pins from our potentiometer, and I'm going to plug it into my breadboard, and notice where those 3 wires are going, which rows that you're in. And so we're going to send the one from the well, again, what I'm going to do is I'm going to I'm going to electrify the rows here, the columns here for my ground and for my 5 volts going into it. So I'm going to take one from ground here. There we go. Oops, sorry. 5 volts for my red wire. And I'm going to put it into this column. I'll just put it at the end to keep it out of the way. I'm going to do my ground, my black wire to the column that has the negative, the black on it. And so now these columns are ones that I can use on my breadboard. So this is always nice to do as well, to start out doing that to get your power how you want it. So for my potentiometer, it has 3 different pins. One that is going to the 5 volts. So I'm going to use the red there on one end. The black is going to be on the other end of my potentiometer, and it's going to go to ground. And then the middle one of the potentiometer, this is what varies. So in the potentiometer, it's something that it can vary between, in this case, 5 volts and 0, and by spinning it. And so the center one is what that output is going to be. And so we're going to send that to, I think we have it going to A0. That's what we have it going to A0. And so the A pins, so you'll notice on your board, on your Arduino board, we've got different rows of things. Let me just stop sharing for just a sec, just to explain. Actually, I can do it on the screen here. Let me do it on the screen. So we've got different rows here. So on this side over here, these are analog pins, okay? So when we talk about electricity and circuits and stuff, we can talk about things being digital, or we can talk about things being analog. So if something's digital, it means that it is, in the digital space, things are on or off, ones or zeros. So it can be in 2 states. It can be either in the 0 state or the 1 state. So usually with electronic, it means, on and off. And so when we look at digital signals, we're sending something that is, either completely off or just completely on. That's what it knows. When we're looking at something that's analog, analog can mean something that's in between that. So it's not just on or off, but it can be between 0 and 5 volts. So there can be a variety of, voltages there in between that. And so that's what the analog pins allow us to do, is to be able to measure those analog signals going into the Arduino. The digital pins that are on the other side, those are ones that we can send signals out or get signals in if something is on or off, or to turn something on or off. So in this case, we want something from the analog, one of the analog pins. Okay. And then let's keep hooking things up here. The next thing we're going to hook up is our servo. And so you'll notice it also has 3 different pins to it, a red, white, and black. And so I'm looking for a white wire. There we go. And so we're going to send the white wire, that is the one on the servo, and we're going to connect that to the 9 pin, the digital 9 pin. There we So that is the control wire. That's the one that is going to send out a signal to the servo to be able to control which angle that it's going to be at. And then we have to get power to our servo to be able to make it run. And so that's what the red and black wires are for. So the red wire goes to 5 volts. And this is just kind of just generally for circuits. Usually red denotes the power one, black usually denotes the ground wire. So black is going to go to the ground. Okay, so there is our simple circuit. It's in there. So it should look something like that. On your servo, if you haven't already, you can get one of the arms, the white arms, to be able to put onto the servo at top, and that just makes it so you can tell the spinning a lot easier. And there's that. So hopefully everybody's getting this wiring done. So it's not too complicated, this one, but just kind of check your wires, make sure they're all in the right places. And then let's go ahead and plug in our Arduino, get power to it, and let's look at our code. So I'm going to go get my screen here. Let's go to the Arduino app, and we're going to open up a different file here, a different sketch. So that's another, just part of the nomenclature of Arduinos. They don't call them programs, they call them sketches. So this is the sketch we want to do. We're going to do the one that is the servo. So it's 3A, that circuit, 3A. We'll bring it up. Oh, actually, stop share. I don't think it was showing that one. Okay, yeah, there we go. All right. So here is our code for this one. This one's a lot shorter than the other one, actually. So one of the special things we have to do here, since we're using kind of a new piece of equipment, the servo, we're going to add a different library to our to our sketch here. So we're going to add the servo library. So that's what this one here is. This hashtag include servo.h. So this includes the servo library. There are a number of different libraries that you can include into your program. And so basically what that does, so in a program, there are all these different libraries that have different commands that you can use in your Arduino program, okay? If they were just all there all the time in your, for your programs would take up a lot more space and be a little bit slower than they would need to be. So there are these separate libraries that you just pull in if you need it. Otherwise, you don't need it. And so it would just take up space and room. But in this case, we do need, since we have a servo connected, and one of the things we're going to use, we're going to include the servo library. So that's what this hashtag include servo.h is. And we're going to create a couple integers. Okay, so we're going to create a couple different variables here. We're going to have one that's the potentiometer position, and then the servo position. Okay, and so these variables here are just going to keep track of the position of each of those different things. And this is something that can change in our program. And we're going to create a name for our servo, this one that we're using. If we were using more than one servo, we would give them different names. This one will just say that this servo, create a servo object called my servo. If I had another one, maybe I would call that one your servo or something like that. And so then I'd write servo space your servo. And that would create another servo object. So if I had two servos connected, I'd have to have two different names for them to be able to control them individually or separately. Okay, so that's all of the kind of looking at creating the variables for my different objects that I'm using. And then for my setup, I'm going to set up that my servo is attached to pin 9. Okay, so I need to tell the program where I'm going to be sending the information out the output to my servo to get it to move. Okay, that's pin 9. And then in my loop, what I'm going to do is I'm going to read what the position of the potentiometer is. Okay, so this is getting an analog reading of it. Okay, so it's measuring the voltage that we're getting from the potentiometer, right? It can be between 0 and 5 volts. And then this map thing, this is kind of the interesting thing. So we're pulling in this signal from the servo, analog signal, and it's reading it, just what it reads, how the Arduino reads it, is that it reads the potentiometer reading between 0 and 1023. But we want to change that into an angle, right? So if we're thinking about a servo that can go between 0 and 180 degrees, we want to change that, that voltage that's being read between 0 and 1023 and turn it into a reading between 0 and 180 degrees. But there's something that's kind of special about these servos, or kind of finicky about the servos, is that if you get right to the edges, like near 0 or near 180 degrees, they might kind of like jitter a little bit, because they might try to go just a little bit beyond and it can't do that. And so it kind of wavers and wobbles. So just to be safe with your servos, we try and keep them from going all the way to the extremes. So that's why I'm saying we're saying map it onto between 20 and 160 degrees. Okay, so that's going to be converting it's going to be mapping that voltage, which is mapped to between 0 and 1023, mapping it to 20, between 20 and 160. So if we get a reading of 0, that's going to be mapped to 20. If we get a reading of 1023, that's going to be mapped to 160. And then each increment in between is going to be mapped to a kind of a corresponding range in the other thing. Okay. And then we're going to say that for the servo, we're going to write it to whatever that position is for the servo. So essentially what we're doing in our code here is we're going to say we're going to turn the potentiometer, and whatever that voltage change in the potentiometer is, that's going to be converted into an angle for the servo so that we can turn the servo just by turning the dial. So let's go ahead and upload this to our Arduino. Now, here we go. Upload it to Arduino. When you do that, when you're uploading something to your Arduino, you'll notice there are some different lights kind of next to where the, there you go, my lights are picking that, there we go. And so the lights are there showing that it's getting some, its information is being sent into it. So now it is on there. So if I turn my Arduino, or my potentiometer, it should turn my servo with it. Let's see, as I turn my potentiometer, it's turning the servo. So go ahead and try that with yours to see if you are getting yours to turn your servo with that. Stop sharing screen. Is anybody getting any success with theirs? Give me a thumbs up if you are. If not, let me know how we could troubleshoot. All right, so I'm going to give you a little challenge here. So think about ways that we can change the code to do different things. So this is a good thing to do with students as well, to give them challenges. Like if we wanted to do this, what would we change in our code? How would we change our code to accomplish that? So I'm going to give you the challenge here. What would we do? How would we change things if we wanted to make this servo? So right now, when I turn my potentiometer, right, I'm going to turn it, let's say clockwise on here. It's making my Arduino or my servo turn clockwise as well. Okay. And if I turn it counterclockwise, it's making my servo turn counterclockwise. What can we do to make it turn the opposite direction? That if I turn this counterclockwise, would say it's going to make my servo turn clockwise and vice versa. How can we change that? What can we do to modify either the code or our circuit to accomplish that? So go ahead and try it out, test things out. If you have an idea, test it out and see if you can get it to move in the opposite direction than you're spinning the potentiometer. And there might be more than one way of doing it, right? So Trevor's, sorry, go ahead.
I have a weird experience.
Yeah,
Because
go ahead.
I'm exactly using the red board. I'm talking about still the sensor
Mhm.
we're doing it earlier. So I exactly did what you discussed to us, and then since it's not working this one, I used the Uno R3,
Okay.
and it's working like this. It's supposed to be like this, right? The social distancing.
Yeah.
When you place your hand, it will light up,
Uh-huh.
right? So just
Yeah,
like
it
that.
should change colors depending on the distance. So if you move it like closer or further away, it should change colors depending on the distance, right?
Mine is kind of like, yeah, it changes color or it totally get off. Yeah, it turn off if there's no blocking on the sensor. So just like that. Okay. And then I'm using this Uno R3, and then I put it back to the red board. It is not working in this one. So I'm really wondering why it happens. And it's not even working on the online software.
Mhm.
Because I usually practice myself doing this stuff in the online software, because we cannot actually download this Arduino IDE in the school laptop,
Mhm.
even the kids. So it works it worked this time because I'm using my personal computer.
Yeah.
Well, I don't know.
So is it that the code is not being downloaded or uploaded to the Arduino?
I did the same thing, but I don't know why it's not working on the red board, but it works on the Uno R3.
So is the computer not recognizing the red board? Is that what you're saying?
Yeah, it says it's error in when it comes to the copying of message, but I didn't do anything on the code. It's already in there. I just copy and paste it there.
Yeah. So it sounds like it's not the code. I don't think there's anything wrong with the code, right? It's just your connection to the so your red board is not being recognized by the computer as, it's not being recognized by it. And so for that, I don't know a specific thing, but I would look up on the Arduino website how to what's it called? Just look up like red board not being recognized or something like that. And so it'll take you through troubleshooting.
It doesn't matter whether it's red board or just the Uno R3.
Yeah, just Uno, just whatever the board type is.
And how come the codes is not working on whenever I use the online IDE? I mean the online software.
Yeah, so you'll have to, the thing is for the online one, it has to be able to access the different ports on your computer. So if it's the app, the IDE that you download to the computer, it seems to work better at being able to access the ports. So like your USB port to recognize that someone's plugged into it. Well, for the online one, there are some other kind of tricks you have to go through to make it recognize the ports to be able to access those ports. It's just, it's a safety thing, right? So you know, you don't want stuff over the internet necessarily to be able to just access things on the ports in your computer, right? It's a security thing. So there, you'll have to look at how that is. If you give me a minute, I'll look that up as we're going along. I'll try and point you to a website with reference of how to get it to recognize the ports. Okay. But looking at the servo, did anybody get some success in doing that? I noticed I saw in the chat Trevor put in a couple of different things of changing the mapping from instead of from 0 to 1023, make it 1023 to 0, or changing the wires on the potentiometer, just kind of reversing them, right? Flipping them, which is the positive, you know, the 5 volts, and which is the 0. So those are two different ways that you could do it. Did anybody try those and get success in reversing the direction? You're a quiet bunch.
Yeah, I think it worked. It was hard for me to keep track of which way things were turning, but
Yeah. So one thing that you can do with servos is just to mount them somewhere. Sometimes that helps, especially with, you know, student projects or something like that. One thing I like to do is get Velcro strips, and so I'll put Velcro strips on the bottoms of my and this is just for projects for students to do. It just makes it a little bit easier to put things in different places, is to put Velcro strips. I don't have them on this board, but even on the board, I would just put a Velcro strip, one of the sides on the corner of the board and the other one on the bottom of this, so we can just mount it here on the board itself for the servo. It just makes it a little bit easier to hold it in place for them to be able to do that, and then easily take it off. And you know, when you're doing a project that doesn't require that. All right, great. So that is for the servo, how to control the servo. Let's look at, we've about 10 minutes left. Let's just add, let's see, how about, well, actually, with just 10 minutes left, how about we just, I'm just going to open it up for questions for folks, not necessarily just with what we did today, but definitely what we had going on today. But if folks have tried to use Arduinos before, are there any problems that you come across? Or, and so this could be something in which it's not necessarily me answering all the questions, because some others might have come across this too in the projects that you guys have done. But there are any questions about Arduinos or things that you're wondering, even if you haven't come across it yet, things that you might think, I'm not sure how I'm going to do this, you know, later on in the year. Any advice?
I do have a question about kind of the statement you just said. How do we do this later in the year? We kind of struggle at our school because we don't have Mesa as a class.
Okay.
And so we do it at lunch, and then, well, we would like to do it in the afternoons, but not many kids show. What advice would you have for independent, like having them come when they can? Do you think that's something, like if we just had just let them independently do it, what would you do?
Yeah, so one thing that I find is good is to create little kind of cards for students to use, so with different projects on them. So for instance, like the different projects that we had today, you could do those too, but also within this guide. Let me pull this guide up really quickly. And so it's not in card form right now, but what I might do is, you know, there are a number of different projects in this guide, and kind of starting at the very beginning and kind of building up to more and more advanced. And so what you might do is, for one of these earlier projects, just take, like here's one for the potentiometer with the LED light. And so I'd create a project here in which I have a sheet, and I usually laminate these just so I can use them over and over again. And on one side, I would have my hookup guide like this. Okay, so they get familiar with this, and it's something independently they could hook the things together. And on the other side, I would put the code. The guide doesn't have it. It's in the examples that has the code there, but I would print that off and put it on the back as well, so they can look at the code too, so they could visually see the code. And we could do it front and back, or you could have two separate sheets so they could look at it at the same time. But that might be something that would be allow them to, because once they've gotten the idea that, okay, I hook up this circuit this way, and this is the code that I use, then that's kind of the steps they would have to do for any of these different projects. The extension part of it would be then giving them some questions after they've done the project. And this does have some of those, where is it? Coding challenges. So this could give you some challenges for that project too. So for this one, where it had the LED lights and the potentiometer, then it says, could you, and the code has it so that you have it blinking, and you change how fast it blinks by turning the potentiometer. Now, this gives you some other challenges for them to do, right? Can they change, by using some math in their code, change what the pause is in between the blinking, or can you add more LEDs so that you'll have multiple LEDs blinking at the same time? How would we add that to our diagram here, right? How would we do that? We just have kind of replicate this and put it into a different, have like a green LED and a blue LED with the same type of wiring for it. So that could be a way to make it so that it's a little more like student led, that they can go in different directions, and you don't have to teach them all the same thing at the same time. They can, pick up a sheet and do that one, or, if they've done that already, go to a different one.
Okay, that's perfect. Thank you, sir, so much. That's very helpful.
You're welcome. Yeah, and so this inventor's guide, the SparkFun Inventor's Guide, it's got some really good simple projects, and it's got, if you read through this or look through it, it's got some really good information as well. So even on the hookup guide, it's got the visual. It also has a hookup guide, and this doesn't really help me, but I can see it helping others, where it tells you where to connect the different wires. So each wire, where does one side of it go to and another side of it go to? And so for the LED here, for example, it says, and for the boards, right, they are lettered and numbered, right? A1 and A2 and stuff. And so it tells you for the LED, put the negative side in A1, the positive side in A2. For the jumper wires, have one go to 5 volts on the breadboard, and one go to 5 volts on the breadboard, and so on. So it has different supports for creating these things. Any other questions?
I didn't say they had a question, but maybe Kevin, you can add some light into this. Sometimes where I see that the students have trouble in some cases is they're able to do the basic tutorials and they go through all the steps, but then how that translates to an actual project. And so what I've seen work well is, brainstorming the uses of the different sensors, thinking outside like how that would work. But any suggestions on that, going from the basic projects to translating that to a workable project?
Yeah, I would say one thing is, as we're going through the basic projects, like seeing what the sensors do, that's the time to think about, well, how could we use this for something like for that ultrasonic sensor? Like, what could be a use for something that can detect distances on it? Like, how can we make that do something else? So in the one that we had, it was just changing it from 3 different ranges and changing a light color. But what if, let's say, we wanted it to be auditory. So we could have a buzzer that for different distances, it makes a different tone. So in that case, now we're creating kind of a ultrasonic harp type thing. You put your hand in one distance, it creates one note, different distance creates a different note. So you can kind of move your hand around to make sound in that way. So so just kind of thinking about what are some other combinations that we could have. So using this sensor, it detects, distance. Then what can we have be, and that's an input to the Arduino. What could our output be? Could it be changing a light, the red, blue, or green, or could it be making a sound, or could it be turning a motor? Maybe it gets a certain distance and then, a door opens, like a latch opens or a latch closes, so it's that type of thing. How can we combine those different inputs and outputs? When I'm talking with students, I'm always emphasizing inputs and outputs. This is an input. What's the output we're going to have from that? What are the different types of outputs that we could have? What could this input triggers something? What's it going to trigger? What's it going to be that we're doing? So that's kind of the connections I try and draw with them. And so from that, then they can get their ideas for a project. Now that they know the possible types of combinations that you can have with things.
And the terminologies, Kevin, about input and outputs, if you are interested in doing MESA USA, those are specifically in the rubric is talking about inputs and outputs. So just, look through that. It's for the students to be able to understand those processes with whatever they're using.